Assalamualaikum and hi student. So we are still in chapter 1, function of several variables, and for today's video we're gonna cover the third LO. You should know the concept of partial derivative and chain rule. So but our focus now is in chain rule. Okay, we begin with subtopic 1.5, the chain rule. Okay, the chain rule is a formula for differentiating composition function. Let's see theorem 1.4 for chain rule. Consider z is equal to f uv, a function of uv, such that u is a function of g, x, y. And then v is a function of h, x, y, where f uv, g, x, y, and h, x, y, all these functions are differentiable. Then how you can find del z over del x and del z over del y is using these two formula. So meaning that the chain rule can solve a function in a function. Okay, so del z is del z over del x and del z over del y is written as this, and this is coming from the tree diagram. So this is the tree diagram I mentioned before. Okay, so let's see how this related to this tree diagram. Okay, first let's focus on this del z over del x. Okay, for del z over del x, you see z is a function of u and v here, and then u is a function of x and y, as well as v, a function of x and y. So from how to find del z over del x? So refer to this branch. Okay, the z, u, and x, you have this one. And then another one, you have z, v, and x here. Okay, so to find del z over del x, from z to u, you can find del z over del u. And then from u to x, you can find del u over del x. And then from here, z to v, you find del z over del v, and then v to x, you find del v over del x. So that's why for this one you have del z over del u multiplied by del u over del x, plus with another branch here you have del z over del v multiplied by del v over del x. Okay, and then for del z over del y, okay, so you start with the z and then find the y. So you have z, u, and then y. And then again, plus with z, v, and y. So that's why you have del z over del y equal to del z over del u multiplied by del u over del y plus del z over del v multiplied by del v over del y. Okay, next. The theorem of chain rule has a natural extension to the function of three variables. So for example, you have w. W is a function of x, y, and z. You have x is equal to function of, let's say, st. Y also a function of st. And then z is a function of st. So your chain rule will be, okay, so you start with w, and then you have w is a function of x, y, and z. So you have x here, y, and z. Next, x is a function of s and t. So here you have s, t, right? And then for y you have another s, t. And then for z you have s, t. Now you can find del w over del t. So del w over del t is equal to, okay, see that you start with w and then find t. So you have this one first. For second you have this branch, and the third one you have this. Okay, so here you have del w over del z. This one you have del w over del x. This one you have del w over del y. here you have del x over del s, del x over del t, del y over del s, del y over del t. This is del z over del s, and this is del z over del t. Okay, so from here to find del w over del t, you have del w over del x multiplied by del x over del t, plus from this branch you have del w over del y multiplied by del y over del t. Another branch you have here is del w over del z multiplied by del z over del t. And try to find what is del w over del s. Okay? Continue with the example. The first example, use the chain rule to find del z over del x and del z over del y if z is equal to u square plus v to the power of 4, where u equal to x square cos y, v equal to xy cube. Okay, so for the chain rule, your z function of u and v. Alright, and then you have x and y here. X and y. Then for v, you have x, y. Okay, so they ask you to find del z over del x. So del z over del x is equal to, okay, so this is, from here you can find del z over del u over del x, del u over del y, del z over del v over del x, and del v over del y. So del z over del x, so this is the x. So del z over del u multiplied by del u over del x. And then we have another x here, z to the x. So plus with del z over del v multiplied by del v over del x. Okay, now to solve this, find del z over del u from here. Okay, so z, differentiate z respect to u, you have 2u. Okay, multiplied by differentiate u respect to x. So you have 2x cos y. Okay, plus that this is your z, differentiate this respect to v. So you have 4v cubed. Okay, and multiply with del v over del x. So from here find what is del x, del v over del x. Okay, so you have y cubed. Okay, so the answer from here is 4ux cos y plus 4v cubed y cubed. Okay, so but this is not your last answer. Okay, so you need to substitute your u and v in terms of x and y, because you want to find del z over del x, not del z over del u x v w. Okay, you need to substitute into x and y. Okay, so for u is x square, x cos y, plus 4v is xy cube, y cube. Then this is equal to 4x cubed cos y plus, sorry, this is for your u is equal to cos x square cos y. So this is x square cos y. So cos y multiplied by cos y is cos square y plus y x to the power of 3, y to the power of 9 here, y cube, so you have 9, y to the power of 9 multiplied by y to the power of 3 is y to the power of 12. Continue with finding del z over del y. This is equal to del z over del u multiply by del u over del y plus del z over del v multiply by del v over del y. So this is equal to, again differentiate z respect to u. So you have 2u multiply by differentiate u respect to y. Okay, so differentiate cos y, you have minus sin y. So this is x squared minus sin y. Okay, plus with del z over del v is equal to 4v cubed multiply by this one, you have 3xy squared. Okay, so this can be written as minus 2u x squared sin y plus 12v cubed xy squared. But remember, you need to substitute the value of u and v. Substitute the u and v. So this is minus 2. U is equal to x squared cos y x squared sin y plus 12v cubed is xy cubed. Again, multiply by xy squared. So this is minus 2x to the power of 4. Then you have cos y sin y from here. And then plus with 12x to the power of 3 multiply by x, you have x to the power of 4. And then y cube is y to the power of 9. Multiply by y square is y to the power of 11. So this is our del z over del y. The second example is the chain rule for 3 variable function. Okay, suppose that w in term of x, y and z. Okay, we have xz plus yz with x is in r and s. rs, we have rs for x. Y, we have r only. So we have just r, variable r. And z, we have variable s only. Okay, find del w over del r, del w over del s. Okay, for del w over del r. Okay, so this one, you have del w over del x, del w over del y, and del w over del z. You have del x over del r, del x over del s, del y over del r, and del z over del s. Okay, so del w over del r. So w to the r. So you have del w over del x first, and then multiply by del w over del r. Okay, and then you have del w over del r here. You have another r here. So del w plus with del w over del y multiply by del y over del r. So do you have r here in z? No, right? So you just have these two combination. So this is equal to, okay, so del w over del x respect to x. So this is z. Del w over del x is z multiplied by del w, sorry, this is del x. Del x. Yes, del x over del r. So del x over del r is equal to 1. Plus with del w over del y is z as well. And del y over del r is equal to 2. So from here you have z plus 2z. So you have 3z. Okay. And then z need to be substituted. So z is equal to minus 3s. So the last answer for del w over del r is equal to minus 9s. Right? So del W over del S for this one. So for the S, any S here, so we have del W over del X multiplied by del X over del S. Then you don't have any any S here in Y. You just have S in Z. So plus with del W over del Z multiplied by del Z over del S. Okay. So this is equal to del W over del X is Z multiplied by del X over del S. So this is 2 plus del W over del Z. Okay, so del W over del Z you have X plus Y multiplied by del Z over del S is minus 3. So you have here 2Z plus, or this is minus 3X plus Y. Then what you need to do next is to substitute X, Y and Z. So 2Z, 2 multiplied by negative 3S minus 3X plus Y. So R plus 2S plus 2R. Okay. So this is equal to minus 6S minus 3R plus 2S. And this is equal to minus 6S minus 9R minus 6S. So the last answer is minus 12S minus 9R. Okay, for subtopic 1.6, implicit differentiation. Okay, so in equation containing X and Y, let Y be a dependent variable while X be an independent variable. Then defines implicitly in terms of X. Then Y is called an implicit function of X. Okay. The implicit differentiation is applied in order to find the derivative of implicit function. Okay, as mentioned in theorem 1.5 for implicit differentiation of one variable function, suppose that fxy is differentiable and the equation fxy is equal to 0. Defines y as an implicit function of x. So y is an implicit function of x. Then, okay, to find dy over dx, dy over dx is equal to minus differentiation of x, okay, divided by differentiation of y, where the denominator cannot be equal to 0. So this is for one variable function. The same approach for function with two variables, z is equal to fxy, as stated in the following theorem. Okay, let z be an implicit function of x and y. Okay, so moving to theorem 1.6, implicit differentiation of two variable functions. So let fxy z equal to 0 defines an implicit function f with two variables z equal to fxy. Okay, so this is your implicit function. Then to find del z over del x over del x is minus. Okay, differentiate your fxyz respect to x divided by differentiation of fxyz respect to z. Okay, and then for del z over del y, you have, instead of fx, you have fy. Then you have fz for the denominator. Then you have minus here. Okay, so both fz must not equal to 0. For implicit differentiation, it is very simple. Okay, so you just need to remember the formula. Okay, so for example, 1, find dy over dx if y equal to fx defines the equation y square minus 3y minus 2x cubed plus 7x equal to 2. Okay, so to find dy over dx for implicit function, so basically we have to find negative f x, okay, xy divided by f y xy. Okay, So this is from the theorem. Okay. So this is equal to, okay, so from here, differentiate this respect to x first. So you have minus sign here. So for this one, respect to x, you have 0 here, you have 0 here. And then for this one, you have minus 6x squared plus 7. Divide by, differentiate fxy respect to y. So this one, you have 2y minus 3. Minus 0 plus 0 equal to 0. So this is the last answer. Okay, so you have 6x squared minus 7 over 2y minus 3. The next example is for implicit differentiation for two variable functions. So for this one, we need to find del z over del x and del z over del y. If z is equal to fxy defines the equation z cubed minus xy plus yz plus y cubed equal to 2. Okay, so first for del z over del x over del x is equal to minus sign. Do not forget this minus sign. F x divided by f z. Okay, so for this one, this is equal to minus fx from here is 0 minus y. Okay, sorry, minus y plus 0 plus 0. So this is minus y. Okay, divided by fz. So respect to z, you have 3z squared minus 0 plus y plus 0 plus 0. So the answer is y equal to 3z squared plus y. Simple. Okay. And then for del z over del y, this is equal to minus fy over fz. And this is equal to minus, differentiate this respect to y, you have 0, you have minus x here, okay, plus with z plus with 3y squared over, again, fz is equal to 3z squared plus y. And this is equal to x minus z minus 3y squared over 3z squared plus y. Okay, very simple. So that's all for today's video. Okay, for the next video, we continue with local eczema, which is the last subtopic in this first chapter. Thank you.